Today we're going to talk about concave mirror. Okay, so concave mirror means something like this. Okay, and this side is not shining. So it's not shining. And this side is shining. Shining surface. Okay. So the tricky part is the sign, and the rest of them are pretty straightforward. So the mirror equation is 1 over dO plus 1 over di equal to 1 over f. So this is object distance, image distance, and focus length. So now let's talk about the sign. So that's about the only thing that's tricky here. So the sign is, so when you have a mirror, so this is a mirror, in this case it's concave. So concave means it's like a cave on the shining side. So look at that, this is a cave, right? There's a cave right here. So that's called concave. So concave mirror is also called converging mirror. Converging. So the sign is, so in this case, sorry, so this is the principal axis. It's just some more background. So principal axis, which we have defined before, principal axis. And you want to put your eyes, let me change the color here. You want to put your eyes on the shining side, right? So you will put your object on the shining side. There's no point put your object on the other side, right? So your object is always on this side here. So this is your OBJ object. And your eyes, it doesn't really make sense to put your eyes on this side because your object here and you look into the shining side, right? If you look into the not shining side, you're not going to see anything. So your eye will be on this side here, right? Your eye will be on this side here. Okay, so that's your eye right there. So the sign is that DO, DI, and F will be all positive if it's on the same side as eyes. As where your eyes is. Okay, so that's it. Okay, but once you start talking about all the different combination of mirrors and the concave, convex, and lens, and then you start to get confused. But this is it. The sign wise, DO, DI, F is positive when they are same size as the eyes. Okay, all right. So then remember that, right? So DO, DI, F are positive when you are same size, on the same side as eyes. Okay, so let's do an example here. All right, so this is the non-shining. Okay. So this is your F. That's your F. That's your focus point. Okay, and the focus distance is from the center. This is called focus lens, right? The small f. And this is called focus point. Okay. All right. So because you are on the same side and there's no f here. For the concave, right? This is concave. Your focus points on the left side, right here, on this side here. And there's no focus point on that side. If you have a convex, so if you're convex, that's a convex. So this is, again, this is not shining side. Not shining side, right? Same thing here. And this is the shining side. So your F, it's on this side for this convex mirror. Okay? All right. So you can see for your F, for the concave mirror, your eye would be on this side, right? So your eye will be here. Okay, your eye will be looking that way, right? Your eye will be the same side. The F will be the same side as I. So F is positive always, right? For concave mirror. And for the convex mirror, your F, so your eye will still be on this side, right? Because your object will be on this side here. This is the shining side, right? Your object will be on this side here. This is object. Okay, so we actually kind of like combine concave and convex here. So your eye will be on this side too, right? Because this is shining, right? So this F is negative. This is your F, and this is your focus length, right? So in this case, your F, right, for the convex mirror, F is always less than 0. Okay? Your object, look at that, object is always on the same side as I, so DO is always positive. Same thing here, DO is always positive. Okay? And how about DI? Now, DI can be on either side, right? Can be on either side. So if the DI is on this side, right? So DI will be positive, the same side as I's, right? Right? And DI will be less than 0 if it's opposite side, right? Opposite side as mirror, okay? So same logic here for the convex mirror. All right, okay. So I'm gonna clear that. And how about the magnification factor, right? Magnification equation. So that's M is equal to HI, so the height of the image. And then H of the O, the height of the object, which is always a negative of DI versus DO, okay? So if HI turns out to be negative, then that means it's inverted. Means upside down, okay? Inverted. If HI turns out to be positive, then it's not inverted. Okay? Then it'll be not inverted. If this HI turns out to be positive, it'll be not inverted. Okay? And not inverted also called right side up, right? So right side up. Or you can also say it's upright, okay? So it's just language, upright. And inverted also called upside down, right? All right. So that's it for the sign convention and equation that you use, right? So let's summarize it one more time. So you have your mirror equation, right? Which can be used for convex or concave, right? And convex is the converging lens. A converging mirror, right? Converging mirror. And this one is diverging. Okay? And this is 1 over DO plus 1 over DI equal to 1 over F. Okay? And your magnification equation is M, magnification is equal to HI over HO, which is minus DI over DO, right? And your sign convention is that DO, DI, F is positive if it's same side as I's. Okay, same side as I's. And HI would be positive. If it's positive, then that means it's not inverted. The image is not inverted. If this is less than 0, HI is less than 0, that means it's inverted. 倒过来 inverted means 颠倒了. Okay, that's all we have. And we'll see you until next time.